Hi everyone, welcome back. In this video, what we're going to do is we're going to take a look at Amazon's EC2 instance. Now, I want you to think back to the different cloud types that we were talking about. And I want you to think back to, why you would use different platforms, why you would use SaaS versus PaaS versus infrastructure as a service, etc. But I also want you to think about what it takes for you to turn up new resources, or let's think bigger than that. What does it take for you to turn up a new data center, right? Let's take it from the get-go, right? So let's just say I need a new data center. What does it take for me to turn up that data center? Well, the first thing I'm going to need to do is I'm going to need to find a location. Where is this data center going to be? Now, regardless whether I build a data center or I'm going to rent out rack space in an existing data center, regardless, I need to find a location. Where is that going to be? The next thing I need to do is I need to understand, okay, are we building a data center? If we're not going to build, are we going to rent space? So we're going to have to take care of that. So if we're building, we have to obviously start construction. We're going to need building permits. We're going to need all of that kind of stuff. We're going to need obviously tons of money to actually architect that. A lot of companies now, they rent rack space in a data center that's already built, like a SunGuard or something like that. But again, there's contracts, there's pricing, there's budgeting, there's all these things that I have to factor into once I find, hey, where am I going to host these servers, these resources? The next thing I need to do is I need to order hardware. Now, this is typically something that I need to do up front, where I need to actually go in and I need to say, okay, we're going to fill this with Cisco UCS. We're going to fill this with Juniper routers. We're going to fill this with Palo Alto firewalls. This is what we're going to need. We're going to need to architect this all out, which brings kind of like a sub bullet point. We're going to need that architecture. We're going to need some kind of a plan of what this data center is going to look like. And then once we order that hardware, we have to install it once it comes in. Now, typically, it's not going to come in a week, right? You're not gonna build all this out and all of a sudden, place an Amazon order, check the box your Amazon Prime, and next thing $10 million of Cisco UCS hardware is going to be delivered, or HP hardware is going to be delivered, or whatever hardware is going to be delivered. It takes time to do that. Now, the next thing that we need to do is after we install everything, right, physically in the racks, now we need to actually turn it up and we need to configure it, right? We need to actually go in, we need to configure the routing, we need to configure the switching, we need to configure the servers, we need to install operating systems, we need to install virtualization like VMware or something. We need to install all this stuff and we need to actually configure it and turn it up. And now finally, we're ready to actually go to our development team, go to our Windows folks, go to whoever and say, okay, it's time. What were those servers you needed? This takes a lot of time and a lot of money, okay? So this is something that is really, really hard to do. And this can typically take anywhere from 6 months to a year to actually build out and actually get accomplished. Sometimes it takes maybe a little bit less time. I haven't really seen somebody get through all of this within 6 months. Typically, it takes closer to a year, sometimes even more. So this is where Amazon EC2 comes in. Now, Amazon EC2 is going to stand for Elastic Compute. For some reason, the reason why I pause there is my brain always wants to go cloud first. For some reason, my brain always wants to say Elastic Cloud Computing rather than Elastic Compute Cloud. I have no idea why my brain wants to do that. I feel like it makes more sense. But if you're like me, it's Elastic Compute Cloud, right? So the reason why we call it EC2 is because there's one E and there's two C's, Elastic Cloud Compute. So one E, two C's, EC2. Kind of makes sense. Now, EC2 is going to provide you the opportunity to create and turn up scalable computing resources without the need for all of that upfront hardware and upfront planning and building out a data center or trying to figure out what data center you're going to put these resources in and all that kind of stuff. I mean, yes, you still may need to decide what availability zone you're going to put these EC2 instances in, but you don't really have to go in and say, okay, I need $5 million for physical HP blade servers and all these switches and all this kind of stuff, and I need 5 more racks, and you don't need that. What you can do is you can just simply turn up the EC2 instances that you need, and the reason why this makes things easier is because they're scalable. I don't even know if that's how you spell scalable. Scalable. There we go. Just erase that from your memory, right? So the reason why this is a lot easier is because these are scalable. You can give this, any amount of gig, memory, whatever you need, and because they're considered infrastructure as a service. So when you think back to that video where we went through what are the different cloud services that AWS offers, Again, the reasons why this is so much easier than going through that whole process of turning up data centers and blah, blah, blah is because these are scalable, so I can give them the amount of resources that I need for that virtual server, but it's infrastructure as a service, which means that Amazon is going to take care of things like my networking. I'm not going to have to worry about, the switches and routers and all that kind of stuff. I mean, yes, there are still configurations I may want to make. Maybe I don't want to allow this EC2 instance. Maybe I don't want to give it a default route to the internet, right? I can control that, but at the end of the day, I don't control the router, right? Yes, I can make routing changes if I want to and say, yes, you're not allowed to the internet. Or yes, I can make access rule changes that say, yes, you're not allowed to the internet, or nobody's allowed to talk to you from the internet. But I don't control the firewall that is responsible for dictating those rules. I don't control the router that is responsible for actually routing my traffic. I may control some configuration to this, but it's infrastructure as a service because I don't control any of the actual devices and things that run on it. I also don't control the storage. So whether it's local disk or remote disk, I don't care. All I do is configure that I want a disk, and I configure how large I want that disk to be, and then Amazon was going to take care of that. I also don't control the physical servers. So, whether these are living on HP blades or Dell blades or, some custom hardware like Facebook has their own custom hardware, regardless what Amazon is using, I don't care because my EC2 instance is going to run on whatever they give me. And if they need to migrate that, that's on them. Now, what's on my responsibility, right? So this is all on Amazon. So we'll say this is all AWS. Now, what's on me is going to be the operating system. So if I want to do patching, what version of Apache do I want to have on there? What patch level do I want to have in my Linux server? What version of Linux or Red Hat do I want to have? What middleware do I want to run on that? Right. So, again, when I'm talking about my version of Apache, what do I want to run on that instance? How do I want to install that software? How do I want to configure that software? How often do I want that server to be up or down? Again, all of those things are on me, whereas the underlay, right, the foundational infrastructure that is responsible for running that server is on Amazon, not me. So let's actually pivot over to the Amazon console. Let's sign in and let's actually walk through some of these screens together in a little bit more detail. So now that I'm logged into my AWS console, let's go over to EC2. Now, again, multiple ways to find things within the user interface. I'm going to come over here to compute, even though it's listed up here. I'll come over here to compute. I'll click on EC2. Now, if you folks already watched the quick video where we turned up an EC2 instance, it's still running. So we'll go into that dashboard, take a quick look at it. We'll click on instances. We can see that it's running here. We can see that I have a public DNS name for it and IP address. Let's go ahead and launch a new one. So let's go ahead and say launch instances. Now, here's where we get to the AMI, Amazon Machine Images. Now, the AMIs, if you think about virtualization, if you have any familiarization with Microsoft Hyper-V or VMware, I'm a VMware guy myself, you should be familiar with cloning images, right? Where you build a server, you build a template, you install the patch level that you want, you install the software that you want, you install things like antivirus and things along those lines. And then you save that image, you save that clone image for the purpose of being able to take it and clone it whenever you want. That's what an AMI is. So a machine image is essentially a cloned image. It's a saved clone that you can just go and you can use whenever you want. And there are different versions, different operating system versions, different operating system types, different patch levels, different software pre-installed. I mean, there are literally tons and tons of AMIs that you can pick with. And you can just scroll down the menu here. You can see SUSE, you can see Microsoft, you can see Red Hat, you can see Ubuntu, you can see different versions of them installed. So this is version 16, version 18, Microsoft 2019 server with SQL Server pre-installed. And so there's a lot of different images that you can pick to light up an EC2 instance. The other thing to pay attention to is this free tier eligible. So there are a number of different costs associated with turning on an EC2 instance. Not all of them are free, right? Some of them are, some of them aren't, hence the free tier eligible. Now, that doesn't mean that this instance is always free. You would definitely have a purchased option available for Windows 2019 base. So if you go into this, you'll be able to say, hey, I want more memory, I want more CPU, I need bigger storage. I'm going to go ahead and pay for that, or I'm just going to pick the default free tier. And that would probably come with like 1 gig of RAM, one virtual CPU, and it would just basically be bare bones. So what I'm going to do here is I'm actually going to type WordPress. Now this again is really, really cool because as I type WordPress, I'm going to get two different options. I'm going to get the AWS Marketplace and the community AMIs. Now the differences between the two are the community AMIs are really built by the AWS community and then they're shared, right? So they're basically built by the general AWS community and they're shared with everyone else. The Amazon Marketplace are basically Amazon partners that have built these images and then basically posted them to the AWS Marketplace. It doesn't mean that they're owned by AWS. It just means that they're an approved AWS partner that has essentially posted them to the marketplace for purchase or otherwise. So here I have a WordPress instance. You can read through the reviews, how many people have used these in the past. Sometimes there are even support agreements for these. So as you go and you type as you go and you turn up these instances, you may be actually able to reach out to the partner or the vendor that has posted this and ask them for support and say, hey, your image isn't working. You can click on more info. It'll give you more information to read about. We'll go ahead and say select. Now we're going to have a different pricing video where we talk about the different tiers and the different kind of virtual servers and things you can turn up and the costs associated with that. However, this is a screen when you're lighting up your EC2 instance. If you get this, you want to pay attention to it. You want to try to look at the different costs associated with the different instance types that you may be able to light up. Now we're going to go with the free instance, so we're not really concerned, but just take a note here of how much that EC2 instance is going to cost versus the type, right? Versus, for example, T3 2 extra large, right? We want to remember that that's going to cost us 33 cents, okay? So we'll say continue, and this is where we're actually going to choose that instance. We're actually going to choose what do we want. And if you remember, the T3 2 extra large was 33 cents an hour, and that's going to give us 8 virtual CPUs and 32 gigs of RAM. It's also going to give us higher network performance, right? Because we're going to get up to 5 gigs. Whereas if I go with the free tier over here, I'm going to get 1 virtual CPU, 1 gig of memory, and I'm going to get very low to moderate network performance. Okay, so it's something that you really want to pay attention to. Now, if you scroll all the way down, you'll also notice that some of these you can change the storage type. So if I go with a C5D, for example, even if I go with a large, I get 2 virtual CPUs, I get 4 gigs of memory, but I get SSD drives and up to 10 gig of throughput. So as you're going through this, you're going to want to pick the right deployment model for you, because once you choose this, the only way for you to change it is to redeploy that EC2 instance. There are ways to do that without having to reinstall everything. You basically just create a new instance and you point it to the same disk. So it's really not a big deal. We probably won't get into that in this course. It honestly, it's really easy. It's not a big deal. It takes like 15 minutes. You declare an outage window on a Saturday night. You go in, light up a new instance, point it to the same disk as the old instance. You turn down the old instance, you turn it on, you're finished. It's not rocket science here. We're not building a new space shuttle. The point is that you can't change this on that exact instance once you've created it. So if you can, try to pick something that's gonna actually give you the resources you need. Let's go ahead and say configure. Again, this is probably going to be a longer video because I want to explain to you how these things work in a little bit more depth. I want to explore the EC2 instance a little bit more in depth. Here's where you're going to choose your VPC. Now, what's the difference between a VPC and a subnet? Now, in reality, physically, a VPC is a virtual private network. That's what it is. It's a virtual private cloud. It's a virtualization of all your different subnets and all your different availability zones. Your subnets, by default, you're going to typically have one subnet in every availability zone available within your route. So you see here I'm in Northern Virginia. So, we have 6 availability zones. We have US East 1A all the way through, 1E. I'm sorry, through 1F. So that's by default, but you don't necessarily have to do that. You could create your VPC is going to have a /16 network. So you could use all of those networks in one availability zone if you really wanted to. Okay, it doesn't have to be spread across them. Remember that each availability zone is a physical data center within AWS, within that region. So the region we have is Northern Virginia, and by default, Amazon has created me 1/24 subnet in a physical data center across Northern Virginia. Again, I don't have to do it that way, but the easiest way that I have found to think of this, think of your VPC as a virtual data center. Think of it as you saying, okay, this is going to be where my virtual data center is in the cloud, and think of the subnet that you put it in as your virtual VLAN. So even though it's physically in a different data center, totally fine. Think of it as a VLAN that you're putting it in. So in that case, I don't really care where it is. I don't care what VLAN I'm going to put it in. I'm just going to stick it in the default, and I don't care. Now, assign a default. Assign a public address. There are a couple of things I can choose. If I choose to turn this off, then that means that my server is not going to be available to the outside world. It's only going to be internal. So again, this is something to think about if you're turning up, if you have a VPN connection between your VPC and your on-prem network, which is more than possible, where your internal employees and your campus network can reach the infrastructure services that you're turning up in the cloud. And this WordPress blog is only going to be available to internal employees. We probably want to make sure that this is disabled and we don't leave it as whatever the default is. Now, in this case, I want to leave it enabled, but I could just say enabled, or I could leave it as the default because I want this WordPress server to be available to the outside world. The IAM role. Now, Amazon has a few services to be able to remotely access and administer this WordPress server. If we were going to use that, I would walk you through this. We're not going to do that in this video, so I'm not worried about it. But if we wanted to use, if we wanted to remotely access this, we probably want to set up an IAM role that says, yes, this particular user is allowed to SSH in or allowed to remotely access this server. And then we would want to set up an IAM role to be able to do that. We'll get into that, I think, a little bit later. A number of different options here. Again, you're stopping hibernating behavior. If this is just a development server where, when you're done with it, you just want it to be destroyed and you don't want the couple of extra clicks to actually terminate the instance, you could say, look, when I turn it off, I want it to be terminated. But as long as it's powered up, leave it there running. Couple of other options here. You can, and again, I think I showed this in the last video. Let's say that you were planning on turning up a web server, or you were going to install MySQL or something like that, or you even just wanted to do an update. You wanted to just say, you know what, yum, update, right? You could type in those commands of what you wanted to do here, and then as that server is turned up, it would go ahead and run those commands for you so that it's not an extra step you have to do. It's part of the turn up. Let's go ahead and say add storage. Now here's where you can, again, you're going to pick the different storage that's available to you. So you can pick general SSD, you can pick your provisioned SSD, you can pick whatever you want. It's going to give you a default size of the T tier that you picked. If you change this, there will be a cost associated with it. Again, you can see this delete upon termination. So essentially, once we turn this server off, not only is the disk going to be deleted, but the instance will be as well. Here's where we can also encrypt it if we want to. We can pick the default encryption. We can go and we create a new KMS key if we wanted to in a separate screen and encrypt the disk. We'll go ahead and say add tags. Here's where, again, we would decide how we want to name this server. Again, this is optional. This is not the host name of your EC2 instance, and it's important that you know that. The host name is going to be completely different than whatever the tag is. The tag is just a human label so that when we look at all our EC2 instances, we can tell what they are. If you don't do a name tag, they're just going to come up blank. In fact, you know what? Let's do that. Let's not do a name tag so I can show you what that would look like. Now, here's where we configure the security groups. Now, when you go with an AMI that's pre-configured, so in our case, our machine image that we're using is pre-configured for us, right? It's already got WordPress installed. They're assuming that we're going to put this WordPress server in, some type of public network where we can reach it on the web, on the interwebs. And so they've already created some basic rules for us to allow in port 80 traffic, 443 traffic, as well as SSH. Now, be careful with the SSH because you don't just want to open this up to everywhere, right? So if I were to say anywhere, this is going to be every single IP address in the world. If you're coming from a dedicated organization, like if you're in your corporate network and you have a dedicated IP address, or you're coming from a NATed IP address, you may want to select for the SSH connections, my IP address, because in that case, it's only going to allow you to remotely connect to this instance from the internet if you're sourced from, your company's address. Now, in this case, I don't care. I'm just going to say anywhere, which when you see what happens there, it's going to choose the IP version 4 and IP version 6 wildcard addresses to just be anywhere. If I say custom, that's where I can choose an own custom address if I want to. So we'll say review and launch. This gives us an opportunity just to double check, make sure everything is the way that we want. And we're just going to go ahead and say launch AMI. Now, this is where we need to select an access key. if we're going to SSH into the instance, by default, our instances are not, and this is for remote desktop as well, they are not just going to accept a user ID and password. We're going to need this SSH key in order to access our instances. In the case of Windows, what's going to happen is it's going to ask you to install the key. It's going to ask you to pop in the key when you actually go to create the remote desktop connection. It's going to offer to download the remote desktop icon for you that's pre-configured with the password. What's going to happen is you'll have to give it the SSH the key first, the SSH keys. I say SSH keys, but anyway. So you're going to have to give it the key first. And then once you give it the key, it's going to allow you to unlock the password so that you can then download the RDP icon. So you're not just going to be able to RDP or SSH into your instances without a key. Now, I have a key already created. To create one, it's relatively easy. You just say create a new key pair. You give it a name. So, if I was going to say demo123, all I would do is then say download the key pair. What Amazon will do is automatically generate a key pair for me, okay? Or I could proceed without one, which is really not what you want to do. So I'm going to choose an existing key pair. We're going to acknowledge that I'm going to use the existing one. I have it downloaded already, so we're going to say launch instance. And now our instance is going to go ahead and launch. So what I'll do is I'll pause the video here. We'll come back once it's launched and once it's set up, and we'll go ahead and test our WordPress site. So I'm finished with deploying my EC2 instance. You can see here that it says, hey, congratulations, your instance is launching. We'll go ahead and say view instances, and this is going to bring us to our EC2 console where we're going to be able to see the instances that we've launched. Now, first thing I want to point out is notice how my new WordPress instance does not have a name. So what I'll do here is I'll give it WordPress. So we'll just say WordPress, we'll say demo. And we'll say save, but the reason why it's blank is because we didn't give it a name tag when we first deployed it. So if you're deploying multiple instances at once, you may want to think about giving it a name tag because it's pretty important. So let's click on the instance here. So we'll click on the instance ID. This will bring us to all the information about that instance. It'll be able to give us the AMI. It'll be able to give us the AMI location. In other words, where was this stored within the AMI, within Amazon AWS. So again, this is great because if I don't know, if somebody else deployed this and they're no longer with the organization, I can go in and I can see where the image was actually pulled from, what version was it, etc. Now, this is our public DNS name. We can either open the address or we can open the URL to actually see if we can browse our WordPress site. And then here's our internal web information. Let's go ahead and say open address, and we'll go ahead and say yes. Now, this is probably upset because we don't have because we have a self-signed certificate for our WordPress site. But here it is. Here's our WordPress site. Here's our blog. We can go back in and add a new a new certificate if we wanted to. The reason why it gave us that error was probably because it was self-signed. But now we have a WordPress site that's up and running. If we go back to our instances, we can see this is our t2.micro. Our free WordPress blog is up and running. So I know this video was a little bit longer, but I wanted to make sure you guys understood your EC2 instances a little bit more in depth than just blindly clicking through the screens. Hope you guys enjoyed this video. We'll see you guys in the next one.